application of Snell's law on refraction through prism. So the prism has got two surfaces, refracting surfaces. So refraction takes place in the first phase AB, and the ray will pass through the prism, and refraction, second refraction takes at the phase AC, that is second phase. Already we have R1 plus R2 is equal to angle of prism, and angle of deviation is equal to angle of incidence plus angle of emergence minus angle of prism. So applying Snell's law in the first phase, Snell's law, applying Snell's law in the first phase, phase AB, this phase. In this phase, this is refractive index of the surrounding medium, and this is refractive index of the prism material, and again this is a refractive index of the surrounding medium. Therefore, refractive index of the surrounding medium into sine of angle of incidence, sine of angle of incidence is equal to refractive index of the second medium into sine of angle of refraction, this one's angle of refraction R1, or we can see mu2 by mu1 is equal to sine I by sine R1. Mu2 by mu1 is equal to refractive index of the prism material with respect to refractive index of the surrounding medium, or we can write it as mu 2 1, since refractive index of the prism material is equal to mu, and refractive index of the prism and refractive index of surrounding material air, which is equal to 1, we can write. So in general we can write mu2 minus, which is equal to mu2 by mu1, or we can write mu2 by mu1 is equal to simply mu, refractive index of the prism material, is equal to sine of I by sine of R1. This is one relation, that is mu is equal to sine of I by sine of R1. Second, at the second phase, phase AC, it means this is R2 is the angle of incidence for the second phase. Therefore we can write sine of R2 into refractive index of the prism material, mu2 is equal to refractive index of the other side, that is mu1 into sine of angle of emergence, mu1 into sine of angle of emergence, or mu2 by mu1 is equal to sine of angle of emergence divided by sine of angle of incident at the second phase, or we can say mu2 by mu1 as mu, as explained here. Mu is equal to sine of E divided by sine of R, this is sine of R2, sine E by sine of R2, So this is another relation, and mu is equal to, we can write mu is equal to sine of E, angle of emergence, by sine of angle of incident at the second phase. So this is a relation on application of Snell's law on the two refraction at phase AB and phase AC. Now, from this relation, this is relation 1, this is relation 2, we can see. From this relation we can write, from this sine of R1, sine of R1 is equal to, sine of R1 is equal to sine of I divided by mu, or R1 is equal to sine inverse. You take the sine that side into sine of I by mu. So from this relation, sine R1 comes here, mu goes there. So we write this way, and R1 is equal to that sine go that way, and R1 is equal to sine inverse of sine of angle of incidence divided by refractive index of the prism material. Also, we have the relation R1 plus R2 is equal to A. R1 plus R2 is equal to A. R2 is equal to A minus R1, where R1, this is the R1, relation of R1, sine R2. Now, from this relation, sine E is equal to mu into sine R2. From this relation, that is, sine E is equal to mu into sine of R2, or mu into sine of R2. What is R2 is equal to E minus R1. That is sine of E. Sine of E is equal to, or if you take this, we can put the value E is equal to sine inverse of sine, that goes that say mu into sine A minus R1. Sine A minus R1. So we can put the value of R1. R1 is equal to this value. We can put it here. Therefore, E is equal to sine inverse mu into sine of A minus sine of A minus R1. R1 is equal to sine inverse of sine I by R, bracket closes, all the bracket we have to close. Therefore, we can write E is equal to sine inverse of mu into sine of A minus sine inverse sine I by R. And angle of deviation is given by angle of incidence from this equation, angle of incidence plus angle of emergence minus angle of the prism. Or this we can write it as I minus A plus E, angle of deviation. So angle of deviation is equal to I minus A plus E is equal to sine inverse of mu into sine of A minus sine inverse sine I by this is mu, not R, mu by mu, bracket closes. It means from here we can say angle of deviation is equal to I, A, and sine inverse of mu sine A sine inverse sine I by A. Or we can say, since A is the constant, because for a given prism, angle of prism is constant and the refractive index is constant, and angle of incidence, this is angle of refractive index. So we can say angle of deviation is function of incident angle only. Therefore, the angle of deviation depends on angle of incidence. This is